Hey there! Yeah, you! Have you ever gone for a run or a drive where you relied on a shuffle feature to play your favorite tune? Has the shuffle button ever done you wrong? Does it ever play old Justin Bieber music from the 2000s? Well, don't worry, I've got an experiment that will soon change that. That's right, folks. Today we'll be answering that age-old question. How well does Spotify's shuffle button understand my music interests? Is it truly random? I turned to the interwebs to find the most randomest music ever and created a playlist containing 10 songs. 8 songs that I'd never heard of, and 2 songs that I saved a while ago. The goal of today's experiment is to identify how many shuffles it'll take for Spotify's shuffle button to play a familiar song. This experiment is a geometric distribution, as once again, the procedure is to keep shuffling until a familiar song plays. One trial is equal to the number of shuffles it takes until you recognize a song. There will be a total of 5 trials, meaning we'll perform this experiment 5 times. The p-value here, or the probability, is 20%, as there are 2 familiar songs out of the entire 10-song playlist. X represents the number of times it takes for our first success. To create the probability distribution table, I use the equations for geometric PDF distributions, mainly because I'm looking for exact answers. As you'll see here, the first row contains your X values, which represent the number of times it takes for your first successes. Basically, the number of times you have to press the shuffle button. So if you're pressing it once, you're going to have a probability of 20%, or 2 out of 10, because remember, we have 2 songs that we're familiar with, and 10 songs in total. If you're pressing the shuffle button the second time, you're going to have a probability of 16%, a third time 13%, and progressively, as you continue to press the shuffle button, the probability of it occurring on your first success goes down. To calculate the expected value of the experiment, all you're going to do is multiply the X value by its probability. So in this case, 1 times 0.2 plus 2 times 0.16 plus 3 times 0.13 plus 4 times 0.1024, and so on. And eventually you're going to get 3.4044, which rounds to 3.4. So this here is just a graph of the probability distribution table. What results would be classified as unusual and why? So because we have an average probability of 0.09, and this was configured by adding up all of the probability and dividing it by 10, the standard deviation is the square root of Q over P squared, which in this case is 0.8, because those are the songs that we are unfamiliar with, over P squared, so over 2 squared, because we are familiar with 2 songs, and in this case it equals 4.47, and that's our standard deviation. Anything that is 2 standard deviations away from the mean, so anything that is more than 4.47 away from the average probability of 0.09 is unusual. And on that note, let's just go ahead and get it started with the experiment.
Save a piece of me. Pizza party at your house. I went just to check it out. 19 extra larges, what a shame. No one came, just us eating all alone. You said, take the pizza home.
I woke up, drove to the store, bought me a Dell PC. 100 megahertz processor speed, this is all you need, he said. Trust me. I opened it up as soon as I came home. Please hold my calls, cause I'm using the phone. Dial-up modem, analog.
Neu in der Klasse und ein Hühne von Kind. Und der hat Hände wie Stahl, die groß wie Kohlenschaufeln sind. Auf unserem Schulhof, da wird nur gemunkelt, dass wir...
Snoopy Cat is my beloved kitten. There's a little black kitten with very green eyes and such a curious nose. That is my beloved kitten. She's all black with big shiny eyes and a tiny cold nose.
This is a man.
And now for the results. So for the first trial, the number of shuffles it took to play a safe song was 3, and the second was 7, the third was 6. Average number of shuffles it took to play safe songs was around 4.4. So here I just have a bar graph of the results of the shuffle button experiment. And before we go, I just wanted to talk about one last thing, and that would be confounding variables. So I didn't listen to the random songs at all, which might affect my results if the Spotify Shuffle feature uses any type of recordance of how often a song plays. I'd also like to note that because of this possibility, I decided to use songs that I saved years ago and haven't listened to since then. So the Ma Be Easy by Fabulous and, the band, whatever. So those songs. That way it wouldn't come up on any recently played or listened to the most recordings. This way the experiment can be performed solely based on the idea of how well does Spotify know my music interests. I imagine there's some type of feature on Spotify or some kind of knowledge where it takes into account what kind of music genres one listens to, and through the Spotify Shuffle would be able to infer out of the 10 songs in my playlist which one I'd like to hear first.